All right, so this is the first of two lessons that finish this chapter of 3, not finish the unit, but finish chapter 3, which is focused on the graphs and understanding the graphs of quadratic functions. And most of this chapter so far has been looking at vertex form. The last lesson was a little bit on standard form, but mostly that's kind of a lead into here, which is eventually looking at how we can take equations in standard form and put them into vertex form. And that was introduced a little bit in the final problem from the last lesson. So we're going into much more detail here. But that said, first, I have a whole bunch of quadratic functions that have a blank constant term. And for each of these, we want to fill in the blank to make it a perfect square and then factor. And if something is a perfect square, the factors should be really simple. The factors should be the exact same binomial squared. And so, for example, x squared plus 2x plus something, if there's a 1 right here, this will be the same as x plus 1 squared. All of this, same as this. And remember, if I look backwards, I've been mentioning this a fair amount in the last few lessons. If I go this way, I know the first term is always the same as this squared. The last term is always the same as this squared. The middle term is always these two times each other times 2. So we're kind of looking at this in reverse now. But that's a nice one to start with. For the next one, if I want to make this a perfect square, I need to have a plus 4 here, because x plus 2 all squared will equal that. The next one, what would have to go here? Well, first of all, I will say, I know if I were to factor this, it would be x minus something squared. I know it's going to be minus because there's a 6 right there. So what term would go there? Well, remember, I said this middle term, if we look at this the other way around, is always the same as this times 2. So x times something times 2 equals negative 6x. This has to be a 3. X times negative 3 times 2 is negative 6x. And if that's a 3, then this must be a positive 9. And so more and more we want to look at a sort of pattern about how to go from here to here, whereas we're used to going from here to here. Makes sense. It's always going to be a bit less straightforward looking at it backwards. So let's look at these. What if I have a minus 10? Well, again, I know the factor is going to be x minus something squared. And so from before, this must be a 5. And if I'm not sure, go x times negative 5 times 2 is negative 10x, which means this last term must be 25. So what's really happening here is I'm always performing the same 2 steps to figure out these blanks. And for this one here, it's going to be x plus this middle term, this last term here is always exactly half of what we have here. So in this case, it's going to be 1.5 or 3 over 2, I'll write it as. And the last term here is always the same as whatever is here times itself. 3 over 2 times 3 over 2 is 9 over 4. And again, everything I'm saying is the reverse of what we were doing every time we would look at a binomial and square it to go to here quickly. And so the second last one, because the last one's really a generalization, in this case, when I factor this, it's going to be x minus half of 9, so 9 over 2. And the missing term is going to be 9 over 2 times itself, so 81 over 4. And so in general, what's always happening here? Because at this point, I can generalize this. Well, whether I have a plus or minus here, actually let's put the plus or minus, I'll highlight. I know when I factor this, it's going to be x, the same plus or minus. If there's a addition sign up there, it's going to be x plus something. If it's minus, it's going to be minus something. I know the term we have inside the brackets for my factors is always half that b value. So whatever we have here, this is always half of it. And whatever comes right here is always this b over 2 squared times itself. So it's always the same as b over 2, all of it squared. And so what I have here is generalizing what we've been doing. If you ever want to find if you want to create this perfect square, I know the last term can always be found like this, by taking the middle term, dividing it by 2, and then squaring it. Always, 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 always. So what's the point of this? Well, we can use this to complete the square. We can use this to take an equation in standard form and write it in vertex form. Now what I have here, I believe, is identical to how we finished off the last lesson. However, I want to approach this a little bit differently now that we've had a bit more of a lead-in. There's lots of ways of doing this. So first of all, let's realize this is not a perfect square. That 10 is not a perfect square. So I know this is not already a perfect square. I want to create a perfect square out of this. So what I recommend first, actually, at this point, is to focus on what matters. And what matters is the x squared plus 6x. The plus 10, no offense to it. It doesn't matter right now. I'm shoving it off to the side. I'm not forgetting about it. I'm not paying attention to it for a moment. I want to create a perfect square right here. And so what would I need to create a perfect square here? Well, I just commented that to create a perfect square, the term that would go here is always half the b value and then squared. So half of 6 is 3. 3 squared is 9. So I know there must be a plus 9 here to create a perfect square. That's it. I just changed my function. I just added plus 9 to my function, which means I need to balance this out, or else I've just changed my function. And it's easy to balance it out. Just put minus 9 right beside it. There we go. It looks messy, but everything is equivalent to before. And the important part is that everything you see in blue, I now know is a perfect square, so I know I can factor it to just x plus 3 all squared. Again, what goes here is always exactly half of that. And then over here, I can just combine these like terms. Negative 9 plus 10 is positive 1. And now I have an equation in vertex form. Right, we can see the vertex. The vertex is at negative 3 comma 1, whereas I couldn't see that before. And so notice, while this is a little bit different approach than I took from the last lesson, and again, please don't think that how I'm approaching any one way I'm approaching something is the only way. I'm just approaching things that I think at this point are the easiest to explain. But in this case, it actually didn't take very long. It all is built upon realizing that if I want to find a perfect square, first realizing this isn't a perfect square already, and then realizing, okay, it's not a perfect square, let's just ignore that 10 for a bit. Focus on making that a perfect square, completing that square, and then making everything balance out. All right, so let's look at this one. No easier, no harder, same idea. So again, what matters is this. I want to make a perfect square out of that. The plus 5, I'm just going to leave it alone for now. So I'm going to write x squared minus 4x. And that plus 5, let's put it over here. Okay, let's make a perfect square out of this. Again, the last term is always going to be the same as my b value divided by 2 and then squared. So negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. So it must be a positive 4 here. The moment I write that down, I've changed my function. I need to balance it out, and I'll balance it out right now by putting a minus 4 over here. Okay, that's the main part done, because now what you see highlighted in blue is indeed a perfect square. And so I know the factors must be x minus 2 all squared. Because again, that's just kind of building on what we did at the beginning of this lesson. This here is always exactly half that b value. Always, always, always. And then right here, minus 4 plus 5 is positive 1. There we go, I'm done. Now it's in vertex form. I can see the vertex is at 2 comma negative 1. So what can make this a bit more challenging? Well, there's several things. One is when you have a coefficient in front of the x squared. In this case, 3 in front of x squared. My a value is 3. It's not a huge deal, but it's a deal. Okay, so that 3 is going to be my a value. I know that's a vertical stretch by a scale factor of 3. What I want to do, though, is I need it to be factored out to be in vertex form. However, I still really don't care about that negative 9, so I'm going to do a few things here. I'm going to rewrite this as 3x squared minus 12x, and I'm just going to shove the minus 9 over here. However, that 3, I want to factor out just from these terms. I could factor it out from the 9 or negative 9 as well, but I really don't care about it right now. So I'm going to take out the factor of 3 from these first two terms, and I get x squared minus 4x. I'm going to give myself some space right here. Because now, again, right, I know that 3 is my vertical stretch by a scale factor of 3. I want to create a perfect square right here inside these brackets. So again, what's going to go here to make it a perfect square? I take negative 4, I chop it in half, I get negative 2, I square it, again I get positive 4. Okay, and now I got to be really careful. I got to balance this out. If I just write minus 4 here, that won't be enough. Because although I wrote plus 4 here, that's not actually how I changed the function. Yes, I wrote plus 4 here, but everything inside there is being multiplied by 3. So really, once I wrote down that plus 4, I really added 12 to this function. Because everything inside those brackets is being multiplied by 3. And so I'm going to add 12 to the function. To balance it out, I have to subtract 12 from the function. Now everything is balanced out. And now everything's going to come together quite nicely. So we see in blue is a perfect square, same as x minus 2 all squared. And then my my constant over here, negative 12. Take away 9 is negative 21. Now it's in vertex form. So I can see the vertex is at 2, negative 21. I can also see it opens up with a vertical stretch by a scale factor of 3. Keep in mind, I could see that vertical stretch right away, but I couldn't see the vertex right away. Hence, what we had was not in vertex form. Okay, so let's look at this. Let's write this in vertex form. Same idea as before, but now we have a negative in the front, so we just got to be a little bit more careful. So again, I'm going to factor out the negative 5, my a value, from just the first two terms. So I have x squared plus 14x. And I'm going to give myself some space and the minus 100 off to the side. Next, I want to create a perfect square right here. So what's going to go inside there to make it a perfect square? Whatever goes here has to be half of 14, so 7 squared. So plus 49. All right, I've now just changed my function. How do I have to balance it out? Well, yes, I wrote down plus 49, but really it's being multiplied by negative 5. So it's negative 5 times 49, which is, calculate that, negative 245. So when I wrote that plus 49 inside the brackets, I actually subtracted 245 from this function because it was multiplied by a negative, which means I have to add 245 to this function to make it all balance out. Now the hardest part is done, and now in vertex form, it's going to be negative 5 times the factors of this, which again, no surprise, should be x plus 7, all squared. And then right here, 245 minus 100 is 145. There's my vertex form. The vertex is at negative 7, 145. There's a vertical reflection and a vertical stretch by a scale factor of 5. All those things I can see there. Okay, so with that said, if I now want us to finish this off by sketching this function right here on the graph, I can do so by kind of utilizing what we just learned. I will say one thing I can do right away, or one thing I can tell right away, is I know I have a parabola that opens down, and I do know the y-intercept is at negative 5. That negative 5 is my y-intercept. So I do know that. In fact, I can place that right away. However, that's about all I know right now in terms of details. I know it's opening down because there's a negative in the front, but I don't know where the vertex is. But at least I know something. Going forwards, though, I really need to put this in vertex form to visualize this function properly. And so again, my a value is negative 1, or a negative, so I want to factor out the negative from my first two terms. And again, if it helps to put a little 1 here, then put a little 1 here. So I have x squared minus 6x, give myself some space, write the minus 5 over here. So I factored out the negative 1. Easy to miss that. Everything inside here, I want to create a perfect square, which means that missing term will have to be half of negative 6 squared, so plus 9. Okay, now I need to balance out the change I just made. I wrote down plus 9, but it's being multiplied by negative 1, which is negative 9. So I actually subtracted 9 in total from this function. So to balance it out, I have to add 9. And now again, things will come together quite nicely. I don't really need to write that 1. I do need the negative. What you see in blue is equivalent to x minus 3 all squared. And my constant at the end is is positive 9, take away 5, so positive 4. There we go. Now it's in vertex form. Now I can really put all this together. I know the vertex is at 3, 4. So let me show that right now. 3, 4, it's right here. I know it's opening down. I know there's no stretch, it's just opening down. So I know my next points will be 1 to the right and 1 down, or 1 to the left and 1 down. I know my next points will be 2 to the right and 4 down, or 2 to the left and 4 down. And while I already have a lot of points, I also, don't forget I knew about this y-intercept at the start. And so I can actually visualize one of the point nice and quickly, because don't forget, all quadratic functions, all parabolas are symmetrical. And so I can just kind of imagine there being a reflection line there. I know there must be another point right here. So now what is that? That is 7 points I have plotted. It's pretty tough to sketch this wrong when I have 7 points to kind of connect. And so I have a really accurate, and once I had my equation in vertex form, a really quick sketch of my function, f of x. So with that said, there's definitely more we have to talk about for completing the square, but this forms the foundation of this idea of completing the square, which really allows us to go from standard form back to vertex form relatively quickly, at least so far.